Okay, so hello. So today I'm going to discuss behavior of lights in optical devices. So since um, we didn't have our synchronous class due to some uncontrolled circumstances, so I'm going to record this discussion. So we have our lesson 3. We have behavior of lights in optical devices. So Introduction. Optical devices form images of objects based on the light rays that interact with them. Take note, we have light rays. Okay, so mirrors form images using the reflected rays, whereas lenses uses the refracted rays. Take note, mirrors, we have reflected rays. We have lenses, they use the refracted rays. Diba, we already know that we have what we call our reflected rays and we have the refracted rays. So for mirror we use reflected and for lenses we use refracted. Take note of that. Okay, then we have image formation in mirrors. So mirrors are optical devices that permits the reflection of light. We have here permits the reflection of light. It demonstrates the law of reflection. So that demonstrates the law of refractions. And mirrors can be planar or spherical. And take note that spherical mirror can be convex or concave. So for plane mirrors, it always form an image that has the same size as the object. Take note for plane mirrors, same size as the object. Okay? The image is same size as the object. The light rays incident to it is simply bounce back and do not change their direction with respect to how they approach the mirror. So it will just bounce back. So example, we have here our light ray, then it will just bounce back. Okay, so it will just bounce back and will not change direction. Okay, the image form is erect or upright. So if you have here, look at here, we have the plant. So the image form is also erect and upright, the same as what is seen. Okay, then we have the spherical mirrors. It has the shape of a piece cut out of a spherical surface. So the piece, okay, it is out of an spherical surface. So two types, we have the concave or the convex. The focal point F is the point where as the reflected rays focused as they leave the mirror. So we have here the focal point is that it is the point wherein the reflected rays are focused when they leave when they leave the mirror. So always remember that. And take note, we have here the focal length is the distance between the focus and the mirror. The focal point is the real, okay, is real for a concave mirrors. Take note that is real for concave. The real focal point for any mirror is located in the same side as the object. The location is along the principal axis and midway between the center of curvature. So we have the center of curvature that's denoted by capital C. The principal axis is the horizontal line. That is the horizontal line formed from the center of the mirror. That is our principal axis. And we have our center of curvature. That is the point located twice, okay, take note, twice the focal length. That is twice the focal length from the mirror. And the radius of curvature, okay, radius of curvature that is denoted by R is the length from the mirror to the center of the curvature. Okay, take note of that. From the mirror to the center of the curvature. And we have here, okay, the focal point for a convex mirror is virtual. Take note, convex is virtual. For concave, that is real. Okay, for convex, that is virtual. The location of the virtual focus is along the principal axis and midway between the center of curvature C and the mirror. And the paraxial approximation makes use of the light rays that forms small angles with respect to the principal axis. So a virtual focal point for any mirror is located in the opposite side of the object with respect to the mirror. So we have here that is our virtual focal point, that is opposite, okay, opposite side. The image formation for mirror is possible by means of paraxial or partial approximation. Again, our partial approximation uses the light rays, okay, to form small angles. So by doing so, other complexities in the formation of image are taken care of, and only rays that are parallel or close to being parallel to the principal axis are used, okay? Parallel or only close to being parallel. So yun lang yung ginagamit for our principal axis. Okay, now let's go. Okay, so we have here our ray diagram. It is also known as ray tracing. So it can be used to identify the location, size, and nature of the image produced by spherical mirror. So take note, produced by the spherical mirror. So it uses lines with arrows as light rays to trace the path of the light that allows the eye to see the image of an object. So it will use lines for diagrams, okay? So yan yung ginagamit natin for diagrams. Okay, so we have two steps. We have steps to follow in performing a simple ray diagram. So for ray 1, we're going to draw a light coming from the tip of the object. This ray is parallel to the principal axis as it bounces off the mirror, it will pass through the focal point. For ray 2, from the tip of the object, draw a ray passing through the focal point. This ray will be called, I will be reflected back by the mirror. So the reflected ray is parallel to the principal axis. So the intersection of these two rays will be the location of the image. So intersection, okay, intersection of ray 1 and ray 2. So yan yung magiging location ng ating image na ma-form. So we have here, this is illustration of that. So first ray ito, dito we use 3 rays, but we can actually use 2 rays. So we have here first, ito yung object natin. Okay, yung ray 1 from the tip, okay, from the tip, going there siya sa mirror, and it will be reflected, okay, passing through the focal point, okay, it will pass through the focal point. So from that point, okay, it will pass through the focal point. So, dadaan siya dito. Okay, for for ray 2, okay, 1 and 2, this is our ray 1. Okay, for our ray 2, we have here from the point, okay, from the tip, passing our focal point, okay, our focal point, and that will be parallel. Okay, this will be parallel. Make a line, wait, okay, make a line that is parallel to the principal axis. So, ito yung principal axis natin. So, make a line, will be parallel. That will be our ray 2. Okay? So, yan yung magiging ray 2 natin. So, saan yung intersection nila ng ray 1 at saka ray 2? So, we have here the intersection. Dito ma-form yung image natin. Okay? Diyan ma-form yung image natin. Diyan. Okay, so that's how we do our ray diagram. Okay? Now, for a ray diagram of a real inverted image, so the image is located in between. Take note, in between the focal point and the center of the curvature. So the image is real because it is formed by actual ray of light, and it is smaller than the object and inverted. Take note, smaller and inverted. So we have here our illustration. Let's have that one. Okay. Okay, so let's look at that. So we have here our image. Okay. So ito yung ating, okay. So we have here, ito yung ray 1 natin. Okay, then we have here our ray 2. So we have here our image formed. That is center sa ating, um, we have here center sa ating, what we call this, atong center point. Okay. And center of curvature and the focal point. Okay. Na siya in between yung image natin. Okay, now let's proceed. Okay, for ray diagramming, two steps to perform our simple ray diagram. So, by the way, yung kanina, okay, take note this is for a real inverted image. So, yung image will be inverted. Okay, steps to perform a simple ray diagram. If the object is placed in between the mirror and the focal point, take note, it is used, okay, this will be done if ang object is between the mirror and the focal point. The steps must be done in drawing the rays to identify the image location. First, ray 1. Draw a light from the tip of the object reflected back and passing through the focal point. Ray 2. Draw a light from the focal point passing through the tip of the arrow and reflected back parallel to the axis. So, let's have that one. Okay, so ito yung object natin. This is our object. So, from the point, okay, we have here ray 1 from the tip, okay, from the tip of the object reflected back and passing through the focal point. So we have here, this will be, that will be, okay, going to the mirror and, okay, passing through the focal point. So yan yung ray 1 natin. So ray 1. Now ray 2 natin, sabi dito, okay, for our ray 2, we have here, from the tip, okay, so sa ray 2 natin, we have draw a light from the focal point passing through the tip of the arrow and reflected back. So from light ray from the focal point passing through the arrow, okay, from passing through the tip, okay, from this point, okay, so let's have a broken line passing through the tip and reflected back parallel to the principal axis. So yan yung magiging ray 2 natin. Okay, then we have here, okay, so the image, okay, okay, wait lang. Oopsie. Okay. So the object is placed in our ray diagram involving virtual magnified image. The object is placed between the focal point and the mirror. Saan na po ni? Wait lang ha. Okay. So, yun lang. It is on the focal point and the mirror. Okay. Now, okay. Now the image form is virtual and magnified. Take note, virtual and magnified. The image is located at the back of the mirror. Take note again, back of the mirror. So, nasa back of the mirror siya. Okay. Now, let's have here, wait muna. Okay, so now, so sorry, wala na ako naka-resume og record. Okay, wala ko naka-resume og record. Sorry. Okay, so balik ta sa, okay, dali na ta. Concave spherical mirrors. We have here form in large images with respect to their object size. So, the effect of the convergence or gathering of the reflected ray on the focal point in the real side, thus image formed is real. Take note, in large images and it is real. The surface of the mirror has its inner curve facing the object. Incident light rays from the top are reflected down. Light rays are incident to the mirror from below are reflected upward and thus causes the formation of an inverted image. So again, we form inverted image on our concave spherical mirrors. For convex naman, we form virtual images. Light rays incidents to convex spherical mirrors are scattered as these are reflected, results in existence of a virtual focal point and causes the formation of smaller image with respect to the object size. So because the outer face is facing the object, Incident light rays from the above are reflected upward and those coming from below are reflected downward. So yung galing sa taas, reflected upward, as yung galing sa baba, reflected downward. So this will create an upright image. Okay, let's proceed with the next. Okay, so we have here activity. Describe the image of a small light bulb located 40 centimeter in front of a concave mirror with a radius of 64 centimeters. So the focal length of the concave mirror is 32 because, okay, di ba? We have here our radius. Focal length, okay, F is a 1/2 hour radius. So we have 32. Because the light bulb is placed farther from the mirror, the image is real, enlarged, and inverted. We also have here concave, so you can use the table of summary. Then describe the image of a 20 of a pencil placed 20 centimeter from a concave mirror. Again, we have concave mirror with radius of 60. So a focal length of the concave mirror is 30 centimeter because, okay, because the object, okay, this is convex pala, sorry. Okay, this is convex. Okay, convex. The image form is virtual, smaller, and upright. So, tingnan natin yung table. Have smaller, upward, and virtual. So, for convex mirrors. Now, you have here our what we call mirror equation. So, the mirror equation is for both concave and convex spherical mirrors. So, we have 1 over P plus 1 over Q is equal to 2R is equal to 1 over F. So, yung P natin is distance from the mirror. Okay. Distance of the object. Okay. Object. Okay. Object from the mirror. Distance of the image from the mirror. Ang R natin is radius of curvature and F is a focal point, a focal length of the mirror. Now, take note or remember that when the object is in front, okay, front of the mirror, the image is real and the values of P and Q are positive. In front, okay, take note in front. So, if nasa back siya, then that is negative sila. F and R are both positive for a concave mirror. F and R are both negative for a convex. So, okay, positive for concave, negative for convex. Okay, so we have here our magnification. So the magnification of the form image formed by a spherical mirror is given by the equation. Linear magnification is equals to length of image divided by length of object or image distance divided by object distance. We have P over Q. That's absolute value of P over, okay, wait. This is Q over P pala, sorry. This is, okay, this is Q over P. Okay. This is Q over P. Okay, let's check that one. Okay, so that will be, okay, wait lang. That is Q over P. Okay. Okay, so that is Q over P. Now let's go. Example here, we should, example number 1, where should you place an object in front of a concave mirror? Okay, take note, we have here front. That means P and Q are positive. Wherein our R is 180 centimeter to form a real image with half of its dimension. So take note, ang magnification natin, okay, sabi dito, half. Okay, so that means that is already 1/2. Okay, our R is 180 centimeter. So we have here our linear magnification, or let's say LM na lang, that is absolute value of Q over P. So that is equal to 1/2. So we have here 1/2 is equal to Q over P. So we have here 2Q is equal to P. Thus, Q is equal to P over 2. Okay, now take note of this. We have here now, okay, 1 over P plus 1 over Q is equal to, okay, 2 over R. So since meron tayong radius na given. So that will be 1 over P plus 1 over P over 2, that is equals to 2 over 180. Now this will be equal to 1 over P plus 2 over P. This is equals to 2 over 180. Okay, so 1 plus 2, okay, that is 3 over P, that is equals to 2 times 180. Okay, so we have here 2P, cross multiply natin, cross multiply. This 2P times 3 times 180. So we have here P is equal to, okay, we have 540 divided by 2. So this is P is equal to 270 centimeters. Therefore, the object must be placed, okay, the object must be placed 200 centimeter in front of the concave mirror. Okay, so ganyan dapat mag-solve. Okay, next. Okay, how far must a lady stand in front of a concave mirror with a radius of 120 centimeter to see an upright image of herself that is 4 times larger? Okay, take note here, larger. So ano nga yung summary natin? We have here, okay, enlarged, we have concave. So for concave, since inverted siya, that will be negative. Okay, Q is negative. We have here our given. Okay, given we have magnification. Okay, magnification is 4 times larger. Then our radius is equal to 120 cm. So that will be linear magnification is equals to Q over P. This value is equal to 4. Okay, that is since we have here upright image concave mirror, that is 4 times larger, that will be negative 4. Okay, that is linear magnification is negative 4. So we have here negative 4 is equals to Q over P. So we have negative 4P is equal to Q. Okay, so since we already know that 1 over P plus 1 over Q is equal to 2R, we have here now, okay, 1 over, ano yung P natin? We have 1 over P. Okay, plus, ano yung Q? We have 1 over negative 4P is equals to 2 times 120. Okay, now this is negative, so it will be 1 over P minus 1 over 4P. We have 2 over 120. Now, get the common denominator. We have 4P, that will be 4P divided by P, that is equal to 4 minus 1 is equal to 2 over 120. So we have here now 3 over 4P, that is 4 minus 1. Okay? Okay, so dito na lang. So we have 3 over 4P, that is equal to 2 over 120. So we have now cross multiply. 2 times 4P is equals to 3 times 120. So we have 2 times 4, that is 8P is equals to 3 times 120, we have 360. Thus, P is equal to 360 divided by 8. Okay, P is equal to 45 centimeter. Okay, so thus the lady must stand 45 centimeter in front of the concave mirror. So, ganyan dapat yung magiging solution at saka yung sagot ninyo. Okay, so let's proceed with the next one. Okay, we have here, okay, a convex mirror produces an image that is 1/6 the image of an object that is located 10 centimeter in front of it. What is the focal length of the mirror? So, sabi dito, ang magnification niya, okay, magnification is 1/6. And yung the size of an object that is located, okay, object located is 10 centimeter in front. Location ng ating object that is 10 centimeter. So that means yung P natin that is equal to 10 centimeter. Kasi 'di ba yung P natin, yan yung distance ng ating object to the mirror. Okay, so we have here our focal length is unknown. So solution that will be 1 over P plus 1 over Q that is equal to 1 over F. Since focal length ang hinahanap. Linear magnification natin that is equal to absolute value of Q over P that is equal to 1 over 6. So we have here now 1 over 6 is equal to Q over P. So we have P is equal to 6Q. Q is equal to P over 6. Okay. So we have here now, what's next? Substitute natin siya sa value. We have 1 over P plus 1 over Q, 1 over Q plus 1 over F. Now 1 over P, yung P natin is 10, 1 over P plus 1 over, okay, we have here P over 6. That is 1 over F. So this can be written as 1 over P plus 6 over P. Since get the reciprocal of the denominator, that will be 6 over P is equal to 1 over F. Now let's continue. That will be 1 plus 6. So since common man ay the same sila ng denominator, that will be 1 plus 6, that is 7 over P is equal to 1 over F. Now what will be our P? That is 10. So we have 7 over 10 is equal to 1 over F. Thus we have, okay, we have here cross multiply 7F is equal to 10. F equals to 10 over 7, or that is approximately, okay, that is approximately 1.43 centimeters. Okay, question with this? Okay, if there's no question with this, let's go. Okay, so if you have question, just you can message me, or you can yeah, you can message me or ask sa atong klase. Next virtual class. Okay, so let's have another um, lesson. Okay, image formation in lenses. So we have here, can you take note of the following? Lenses are generally clear optical media that allow the penetration of light through them and bend them. So it is classified as converging and diverging. So when you say converging, that is positive. When you say diverging, that is negative. So converging lens are thicker, okay, thicker at the center that at the rim and will converge or focus its refracted rays to a single point. When you say diverging lens, that is thinner at the center than at the rim and will diverge or scatter its refracted rays from a virtual point. Now, image formation in lenses. So the focus or the focal point of a thin lens with spherical surface is the point F, where rays are directed at as these are refracted from the lens. The focal length is the distance between the focal point and the lens. So take note, we have distance between the focal point and the lens, and the focal point is real. For a converging lens and virtual, okay, that is real, focal point is real for converging and virtual for diverging. Okay, so ito yung ray diagramming for ating converging lens. For ray 1, from the tip of the object, draw a light ray parallel to the principal axis. So we have here our ray 1 parallel to the principal axis. Okay, and it will pass through the lens. Pass through the lens, ito yung lens, and converge through the focal point. So it will converge to the focal point. So hit niya yung focal points. Assuming that is a straight line, ang ray 2 natin from the tip of the object that pass through the centers. Ito yung center natin that will pass through the center and okay, extend. Ray 3 from the tip of the object draws a line passing through F. Okay, passing through F. Okay, passing through F and parallel to the principal axis. Okay, passing through F, nara atong F, then parallel to the principal axis. So, diri na din ang ma-form nga image. Inana ang sa ato ang ray diagramming. Now, for ray diagram for converging lenses, if the object is placed beyond the 2f, okay, when you say 2f, this is our 1f, okay, this is 1f, okay, multiply yung ano natin f. F is, 2f is equal to f, okay, times f, or f plus f, okay. So, i-multiply lang ng distance. Example, this is 10 centimeter ang f. So, ang 2f na to is 20, somewhere 20 cm. Okay, so ganyan lang siya. Okay, now, okay. So, we have here, okay, if the object is located between f and 2f, okay, um, f and 2f, a smaller image is produced. So, if there is siya, f, okay, if there is siya sa f, and assuming na dire tong 2f, if na dire ang image, then it will create a smaller image. So, if na siya sa beyond, if na siya dire, okay, mo naman 2f, beyond 2f naman, beyond 2f, that is inverted image. Okay, real inverted image. Okay, so ray diagram for diverging lens. So we have here for ray 1 from the tip of the arrow. Okay, from the tip, it will pass through. It will draw a light ray that diverges. It passes through the lens. So lens, this is the lens, pass through the lens and will diverge going upward. This reflected ray is extended through the focal point. Okay. Then, ray 2, draw a light ray from the tip of the object passing through the F. Asa ang F na to? Okay, so assuming na diri ato ang F. Okay, where's the F? Okay. As the reflected ray is parallel to the principal axis, this ray is extended on the same side as the object. So, mo na siya tong object. Okay, assuming na tong F dire. Okay, nara tong F. Oopsie. Okay, of the object passing through F. Okay, mo na siya. Okay, as a reflected ray. Okay, so assuming mo na siya. Okay, this ray is refracted as the reflected ray is parallel to the principal axis. So, inani siya. Okay, parallel to the principal axis. They draw lights from the tip of the object passing through the center. So, muna siya passing from the light passing to the object passing through the center. Okay, so assuming this is our center here. Okay, na siya. Then, okay, sa ray 1, mo din siya sa ray 1. Okay, so mag-assume ta na dira from the focal, from the tip of the arrow, draw our light ray, then this refracted ray from the focal point. Okay, so ano siya then so there. Okay, so muna siya ang ma-form nga image. And ray diagram for diverging lenses, the intersection point at the same side of the object is where the image is located. So the image form is located in between the center of the lens and F. So nara diri center and nara tong F, nara ang image na form. It is smaller and the object, okay, smaller than the object and is upright and virtual. So for converging lenses, we have here the following. Okay, collect all the reflected rays on a real focus image and okay, collect all refracted rays on a real focus before the image is formed and the focus is placed on the side of the lens that is opposite to where the object is. The image is smaller. Okay, incident light rays coming from above are refracted downward and converging lens are refracted upward. So this kind of refraction results in the formation of inverted image, and that's also real because the focus is located in the real side of the lens. So for converging lenses, direct or refracted rays to a single point known as the focus. The function makes it possible to correct the vision of the far-sighted individuals. So converging lens is used to correct far-sighted individuals. Whereas for diverging lenses, wait muna.